All right, hold on. Let's get this down over here. Okay. All right, so people that are just joining us, today that we are talking about solubility. So far, we talked about solubility. Solubility is the ability to dissolve. Hold on. We said that there's 3 ways to make stuff dissolve faster. Way number 1 was stir. Way number 1 was stir. Way number 2, increase heat. And then way number 3 is
increase the surface area.
Increase the surface area. You guys sound very smart right now. Okay, now we're talking about Kool-Aid. So we said that weak Kool-Aid. All right. So toss me that ball again, Trey. All right. So this is kind of like weak Kool-Aid. So my hands are the solvent, right? And this is my solute. So for my first example, I could still dissolve more solute. Agreed? And what was this called? Unsaturated. All right, because I could still dissolve more solute. All right, thanks for joining. You're all caught up. Okay. Also, did I tell you guys why I'm dressed like a grandpa today?
Because it's dressed like a grandpa?
Yeah, but do you know why I'm dressed like a grandpa?
How are you dressed like a grandpa?
Because I'm retired and I've got my golfing clothes on. I'm ready to go hit the golf course. Hold on. Yeah, that's why I'm wearing my short. Here, let me finish it. Here, now I'm ready. All right.
You look like my grandpa. Like, I think he's wearing that exactly.
I'm telling you, I bet your grandpa's wearing this exact same outfit.
Yeah, I think he does.
Okay. Anyways. Okay. All right. So let's go back to what's tomorrow?
Like truckers versus tiaras.
Truckers versus tiaras.
Wait, what's the thing?
I'm gonna wear a hat tomorrow. I know that. Okay. All right. So back to our Kool-Aid. We're a billionaire. All right. Back to chives. All right. Chives. My butler's name is Alfred because I like Batman. Now my butler's also has a British accent because I feel like butlers should have a British accent. And here it is this hot day. I'm sitting poolside. I'm sweaty, and my butler brings out this glass of ice cold Kool-Aid.
Do we have ice in here?
What? We don't have ice. But
No, we're not rich enough for that.
he's like, and then he says, "Sir, here's your Kool-Aid." All right?
Sir.
Sir. Yes, he calls me sir. I'm a sir. Maybe I've even been knighted at this point. Anyways, so I get my Kool-Aid. And I'm like, "See ya, Alfred." He's like, "Goodbye, sir." And he goes back into the house to sweep or something. All right, Chives. Bye, Chives. And he's like, "Goodbye, sir." Anyways, so I get this Kool-Aid. And when I'm holding this Kool-Aid, I can see the condensation running down the outside of the glass.
Jumping in the pool.
It feels so cool. All right? And I'm just waiting to take a sip of this Kool-Aid. And I take a drink of this Kool-Aid on this 90-degree, 90% humidity day in Ohio. And the only thing I can say after I drink that Kool-Aid is, "Oh, yeah."
I have a question.
Get it? That's what the Kool-Aid man says?
Yeah, we do.
Yes, Annie.
If we're billionaires, why are we living in Ohio?
Why? Because Ohio is a very low expense for living.
Yeah, this is where LeBron James goes.
It doesn't cost very much to live here.
But we're billionaires.
Yeah, so we're trying to save money by living here.
$8
I can get a lot bigger house in Ohio if I'm a billionaire. Red.
Oh.
Classic. All right? All right. So, stay with me. Watch out. There's something on the floor there. This second type of Kool-Aid. All right. Shh. Here we go. This second type of Kool-Aid. Guys. The second type of Kool-Aid. Is that perfect?
Yes.
Refreshing. Tasty.
Let's put that good.
Yes. Amazing. Awesome. You get it. Kool-Aid. This is the Kool-Aid when you take a sip of it and it's perfect. All right? It's that yes. It hits the spot. It hits the spot. So,
I tried to make there's a video where it's like prison Laffy Taffy and they make it with like powder.
No.
we're going to talk about that. All right, we're going to talk about candy making in a second. Not the prison candy. But, all right, so here we go. Trey, toss me one ball. All right, what am I right now?
Unsaturated.
I am unsaturated. Toss me another ball.
Super saturated.
I have two hands.
Saturated, normal.
Are they both full?
Yeah.
So what am I now?
Saturated.
I'm perfect Kool-Aid. All right? I'm the perfect, refreshing, tasty, amazing, awesome Kool-Aid. So what would you call me scientifically? I'm saturated. All right? So I am saturated.
Can I get the saturated?
So we're gonna come back to that on this next one. All right? I'm gonna go to the third type of Kool-Aid first. All right? So the third type of Kool-Aid. This is the Kool-Aid you guys make when you make it.
Cardiac arrest.
All right? How do you guys make your Kool-Aid?
I don't.
You poured a whole bag.
You put too much what? You put way too much sugar. All right? Apparently you guys all want to die young. All right? Now, this third type of Kool-Aid, I'm gonna move this up a little bit. Is now, all right. Here we go. When I add this third type of Kool-Aid, what happens at the bottom of my pitcher? It's that sugary sludge at the bottom Kool-Aid. All right. It's that sugar sludge Kool-Aid. It's that sugary sludge, however you want to call it. All right. It's your notes. All right. This is when you add too much sugar. It's when you add too much sugar. So, here we go. Let's see if we can make this type of Kool-Aid. By the way, what am I now?
Super saturated.
I don't know. We'll see. Let's see if I am super saturated. Let's see if I'm super saturated. Trey, toss me a ball. What am I? Unsaturated. Trey, toss me a ball.
Saturated.
I am now saturated. Agreed?
Agreed.
But if you
All right, so here we go. Hold on. Toss me the third ball. No. Hold on. Let's try again. Let's try again here. Toss me one ball. Here we go. One ball. Two balls. All right, toss me the third ball.
You gotta catch it. You can't. He doesn't have any more.
I can't catch it. Hold on. Let's try one more time. Try one more time. One ball. Two balls. Third.
Oversaturated.
I could cry.
Where is that solute going? He's throwing at me.
Bottom.
It's going to the bottom. So am I super saturated?
Yeah.
No, I'm not.
Oversaturated.
I'm still what? I'm still saturated with what at the bottom?
More sugar.
Extra sugar. Right? So, am I super saturated? No. How could I become super saturated?
Catch the third ball.
How could I become super saturated? What did we do? Stirring, heating, breaking. What did I have to put into all of those situations?
Heat, break, stir.
If I'm heating something, if I'm breaking something, if I'm stirring, I'm adding energy. So, one more try. Trey, throw me that third ball. I'm going to try to become super saturated. All right? So now, I am adding energy. You guys didn't think I could do this, did you? All right? So now, I am adding energy into the system. What am I now? Now, I'm super saturated because I'm continually adding energy. Would you guys agree I'm adding energy? Ooh, I can do one hand. Ooh, look at that. All right? Now, what will happen if I stop adding energy? One's going to eventually fall. Ooh, big finish. So let's see what if it actually falls. If I stop adding energy, it falls back out. You guys can clap for that. That was actually pretty good. Now, here is how. So we're talking about Laffy Taffy. All right. So when I'm making candy, all right, I am super saturating. There's more sugar in here than I can have. All right. And eventually, I stop adding heat. It cools down. If I put a piece of string or a stick down into that solution, as it cools down, what happens to my sugar? It's going to recrystallize, right? That's how you make rock candy, all right? A lot of candy making, Laffy Taffy, you're super saturating a solution. It's all about solubility, and that is how you make it. It's all about saturation. Thank you for not hitting me too hard. So, this third type of Kool-Aid, let's see if we can do this. So this third type of Kool-Aid, all right, I'm going to Add.
Oh my god.
All right. I'm gonna keep going. I don't know if we're there yet. All right. So, ooh, I can taste that in the air.
Good. Come on now.
Tastes sugary.
I've been asking since the beginning, bro.
Anybody ever dye their hair with Kool-Aid?
Yeah, I've been asking since the beginning.
I want some.
Let's see. Do we have sludge at the bottom yet?
No, Jameson, I'm trying to have it with my face.
Maybe a little more.
Are you letting
All right.
My neck tits up.
Oh yeah, you guys will all get to try this.
I'm not trying
But I want to be the first one to try it.
All right. Do you guys all agree there's sugar at the bottom? Do you see it? Do you guys all see the sugar at the bottom? Yes? So, there is now, can you guys see the sugar at the bottom?
Yeah.
Yes? Do you see the sludge at the bottom? There's still sugar. It can't dissolve anymore. I could dissolve this, right? How could I dissolve this? I could dissolving it by doing what? By heating it up, right? I could dissolve it by heating it up. I have a video to show you how you would do this. All right? I have a video to show you how you would do this. This is not a very scientific video, but I think you guys are going to like it. All right, here we go. So let me plug this in. Here we go. There'll probably be an ad. So, how could I dissolve that sugar? Here is how I could dissolve that sugar. Here we go.
It's not with physical products. It's Amazon's other company.
Here we go.
Morning, brother. Hello, brother. I made a pot of Kool-Aid.
You don't make a pot of Kool-Aid.
Well, I did.
Is it hot?
Maybe, maybe not.
It's hot, isn't it?
Yeah.
Hot Kool-Aid.
Put some ice in it if you like.
Oh, no, I'm not thirsty.
Brother.
I'm not gonna drink it. No.
Drink it.
No.
I want you to drink this.
I'm not drinking it.
Drink this right now or I'll pour it on the floor and I'll blame it on you.
Oh, yeah, real mature.
I made this for you.
Now, why don't you grow up?
I do. Because I love you.
Well, I'm not gonna drink it.
I hate you.
That's all I ever hear anymore. Brother, try this. Brother, try that. Remember that? What was it? Cinnamon toast and, what was it?
Mayonnaise.
Mayonnaise.
Good idea.
You didn't make a single pound.
I made a pound of cinnamon toast with mayonnaise.
Don't forget Rocky Road Tabasco, right? Yeah. Was it 3 hospitalized? No, 3 women hospitalized.
You drink this right now!
Drink your own hot Kool-Aid.
There's so much left of it. What am I going to do with all this hot Kool-Aid?
Drink it.
No!
Yes.
No! Brother. Yes. Please. Drink.
Okay.
He said yes.
Okay. Right.
I would drink it.
Depends how hot. Can you make Jello with that?
That's pretty good.
I was gonna say,
I'm gonna freeze.
Yeah, I like that.
Freeze dried Kool-Aid.
You like hot Kool-Aid?
So Braden asked a good question. Can you make Jello with that? This is exactly how you make Jello. All right? What do you do with the water and the Jello first? You heat it up, right? Guys, if you guys understand science, all right, if you guys understand science, there's so much that like of the world. You can really do anything. So Jello, you heat it up. That's one of the first things that you do. You super saturate it, then where do you put your Jello after that? In the fridge, because you're cooling it off. And what does the sugar do? It recrystallizes. Yes, you guys are getting it. Now, draw this little graph on your notes. All right? So we're going to have solubility. I ran out of space. And we're going to have temperature. solubility and temperature. So here's a little graph. Here's a little graph, solubility and temperature. And I am going to put 3 dots. Dot A, dot B, and dot C. So we're going to say what each one of these dots would be of the words we just talked about. So dot A is over the line. So anybody have a guess of what dot A would be, Jameson?
Unsaturated.
It's over the line.
Oh, then it's super.
It's super saturated, yes. So dot A is super saturated. So could we make that type of Kool-Aid today?
Yes.
No, we couldn't.
No, we couldn't.
Because we would have to do what with our Kool-Aid? Heat it. So this Kool-Aid with the sludge at the bottom, the rest of it should taste perfectly saturated. Agreed?
Sure.
Should. We're going to try it in a second. Letter B, right on the line. What would you call that?
Good, good.
Saturated. That's that good Kool-Aid. All right? That is saturated. And then letter C, under the line, is going to be unsaturated. It can still dissolve more. So letter C is unsaturated. Letter C is unsaturated. So you can still dissolve more. Still dissolve more. You guys with me? So the last thing we have to do is we're going to draw water. All right? Have you guys ever drawn a water molecule?
Yeah.
So we call water, we've talked about this. Water is, have you guys ever heard water is the universal solvent? I think I've said that so far this year. It's because water can dissolve almost anything. I'm going to show you why. So draw this little picture of water. Anybody know what water looks like? Looks like Mickey Mouse. So here's oxygen, which is a 2. That's oxygen, which is a 2 minus charge. And then each hydrogen has a +1 charge. So that's water. All right, oxygen has a -2 charge. We'll talk more about charges.
But it evens out, right?
All right, it does because I've got, whoops, that should say +1, not ++. So 2 positive, 2 negative overall is 0, right? But what do you see about water? Does anybody see how it's uneven?
No.
What if I drew a line here? If I drew a line there through water,
Oh, this is, so 1 + 1 is 2, but that's +2, and then under the line is -2.
exactly. Would you agree that water has 2 sides?
Yeah.
What the top side of water is what?
Positive.
Positive. The bottom side of water is negative. Do you know anything else that has one side positive, one side negative?
A battery.
A battery, what else?
A coin. Energy.
A positive side. Magnet, yes. And magnets have a what and a what?
Protons and neutrons.
Poles, right? So water has 2 poles because water is considered a polar molecule. Water is a polar molecule. What's a polar molecule? Well, uneven. It's uneven distribution. Uneven distribution of charge. It's uneven distribution of charge. So, because there's a positive and a negative side, it's uneven. Now, here's why water can dissolve everything. If something negative runs into water, what do opposites like to do? Opposites like to attract. So if something negative runs into water, could it react with the positive side?
No.
Yeah, because opposites attract. If something positive runs into water, could it react with one side of water? Which side? The negative side. That's why water can dissolve anything. And there's other things in there, but when you get to AP Chem, you can learn about that. Now, that's a polar molecule. Let's draw a non-polar molecule. So here would be like carbon. This is the last thing. Hydrogen. Hydrogen. Ooh, that's not. All right. So this carbon has 4 hydrogens all equally around it. I ran out of room. All right, this is a non-polar molecule. Now, on the vocab quiz, which is open notes, all right, on Friday, it's really easy to get polar and non-polar mixed up. Because polar means what?
Cold.
Uneven. But guess what non-polar means? It means evenly distributed. So it's kind of backwards for those two definitions. So non-polar is an even distribution of charge. Non-polar is an even distribution of charge. So today we talked about how to increase solubility by adding energy. We talked about solubility, saturated, unsaturated, supersaturated. What type of Kool-Aid did we make?
Super saturated.
Saturated Kool-Aid with the sludge at the bottom. The only way to make supersaturated Kool-Aid would be doing what? Heating it up. Then we talked about why water dissolves everything. Tonight you do have homework.